Hello friends, welcome to my channel. Let's have a look at problem 491, non-decreasing subsequences. This is today's daily challenge problem. In this video, we're going to explain the method based on bitmask. First, I'll read through the problem statement, and then we do the analysis, and finally we share the code. First, let's look at the problem statement. Given an integer array called nums, return all the different possible non-decreasing subsequences of the given array with at least 2 elements. We may return the answer in any order. So here the main assumption is that we are considering the subsequences, and then the 2 additional requirements are the following. First, the subsequence is non-decreasing. Secondly, its length is at least 2. So here the order is not that important in the return. So here are 2 examples. So in example 1, so here are the corresponding subsequences which are non-decreasing. So notice that 7, 7. So these 2 numbers are the same. So in example 2, so there is only one list which is a valid one, that is 4, 4. So with that said, let's also look at the constraints or additional assumptions. First, the length of the list nums is bounded above by 15. So this is actually an important assumption for us. And secondly, the elements in the list is bounded by absolute value by 100. So with that said, we are ready to do the analysis. So for this problem, so actually we can solve it using bitmask, or we can use backtracking. So in this video, we're going to explain the method based on bitmask. So this method is actually sort of brute force or very straightforward. So the reason we could do bitmask treatment here is due to the constraint or assumption that the length of this list is bounded above by 15. So due to this assumption, if we consider all possible subsequences, so including the empty one first, so the total number is actually 2 to the power n, where n is the length of this list. So this number is nothing but the number of subsets in the power set of a set S with n elements. In other words, it's the cardinality of the power set of an n-element set. So with that said, let's look at the basic idea. The idea actually is very simple. So we want to make a correspondence between the subsequence and the corresponding number or mask. So we consider 2 to the power n numbers ranging from 0 to 2 to the power n minus 1. So both inclusive. And then we consider their binary representations. So for example, 0, it will have correspond to n zeros. So it means that we do not choose any element. And 2 to the power n minus 1, if we look at the binary representation, it corresponds to n ones, so which corresponds to the whole list. So each binary representation corresponds to a subsequence. For example, in example 1, so n is 4, right? So let's consider number 3, right? Number 3 is in between 0 and 2 to the power 4, that is 15. So this 3 corresponding to 0, 0, 1, 1, because the third and fourth bit positions are ones. So it means that we choose the third and fourth element that corresponds to 7 and 7. So this is the corresponding sequence. So then we just need to pick the valid subsequences. In other words, length is greater than 1 and non-decreasing, right? So this is the overall thought, or it's also the basic structure of bitmask method here. So here again, we want to comment that. So this method is sort of brute force. So however, it's good to practice the bitmask technique. It can be effective in some cases. So in a follow-up video, we're going to explain the backtracking technique, which is also one very important and sometimes effective technique. So with that said, we are ready to do the coding. So for the coding, actually it's very routine. We just need to translate this paragraph into coding format, right? So first, I'm going to get the m. The length of this nums is just for convenience. And then we're going to initialize a variable as a result. So this is going to hold the subarrays or the tuples because we need to do some filtering, right? So with that said, let's do the iteration. So we are going to iterate over this range, right? In range 2 to the power n. So it's corresponding to this one, right? So let's use this one. Actually, this is nothing. Nothing but 2 to the power m. Because we are using bitmask, so we are going to use some bit operations. So each mask will correspond to a subsequence. Let's first get the corresponding subsequence, which corresponds to find the binary representation of this number mask. So here I'm going to use this list comprehension directly, right? So nums I for I in range n. So here you can interpret this I as bit positions. So we're going to check if the ith bit position in mask is 1. If it's a 1, we're going to pick the number. Otherwise, we are going to ignore, right? So we want to make a filter. That is, if let's check this ith bit position. So we shift to the right I unit corresponds to do interdivision with divisor 2 to the power I. Then we check if it's a 1. If it's a 1, we are going to pick the element in the corresponding position in the nums list. So with that done, so then we can let's get the length of this guy, subsequence, right? And then we are going to do some filtering. First, if this one is less than 2, so we're going to continue for next mask. Otherwise, so what we're going to do, so you can actually not necessarily use this else keywords, but it's okay. So I'm going to initialize a flag. So we're going to check if the subsequence is a non-decreasing one. So this is actually very easy. It's just a for loop for j in range n 1 up to n, right? Not up to n, sub list up to its length. So here this index will be ending at sub list minus 1, right? This is a very small point. And then we're going to do the check subsequence. We're going to check if this is always maintain a non-decreasing order. If not, so subsequence g minus 1. So g minus 1 is meaningful because we are iterating from index 1, right? So then if this we're going to do a flag, so it's going to be false. So here actually we can, once we have this flag equals false, we can do a break this inner loop, for loop. So then after this one, so we're going to check if flag is true, right? So we're going to append this guy. So here I'm going to use a tuple because the different sequences can be the same. For example, this element is 7. This element is also the same, right? So we're going to do subsequence. So once we do this, because tuple is immutable, so we can use set operation to do the filtering. So then before we do the return, let me first do something like this. I'm going to do a filter for the result. So this will deduplicate the tuples, and then we're going to do the return. So actually we can directly return this result. It still passes. However, because the return type is a list of integers, so I'm going to use list comprehension to do something, to make a conversion. So atom for atom in result. Yeah, this actually forms a solution format based on bitmask. So actually it corresponds to check all the possible subsequences. So with that said, let's first do a check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the cases. So with that said, I guess that's about it for the method of bitmask for this specific problem. This is also the end of this video. So thank you.